Hello students, welcome to PS class. So students, today we will discuss about the iupac system of nomenclature. iupac stands for what? I for international, U for union, P for pure, and A for applied, C for chemistry. So international union of pure and applied chemistry. Now how can we write the iupac name of a particular compound? Now this is the rule for writing the iupac name of a compound. First of all, we will write the root word. Next is your before the root word there is a prefix, and after the root word the primary suffix and then secondary suffix. All total this will give you the iupac name of the particular compound. Okay. Now first of all we will discuss what is prefix, what is suffix, what is root word. Okay. Now first of all prefix. Prefix means before, the part of the name which appears before the root word. रूट वर्ड से पहले जो नेम आएगा उसको हम प्रीफिक्स बोलेंगे. तो ऑलवेज इन ए iupac नेम द रूट बिफोर द वर्ड रूट ऑलवेज अ रूट वर्ड ऑलवेज द प्रीफिक्स इज यूज्ड. ओके. Now it includes some of alkyl groups and functional groups. We'll discuss that later. Some alkyl groups like methyl, ethyl, propyl, these are used as a prefix. For that we can use the prefix. They are always present before the root word. Okay. Now second is what is root word. Root word means it gives the number of carbon atoms in the parent chain. Suppose the organic compound is given to you and not the total number of organic carbon atoms present in the compound. No, that is not the case. Here root word means when you choose the longest continuous carbon chain, then when that is treated as your parent chain or principal chain, then that the total number of carbon atoms present in the parent chain or principal chain can be treated as your root word. Okay. Similarly, what is primary suffix? Primary suffix means the number, the linkage which is present between the carbon-carbon bond. Okay, it indicates the nature of the carbon chain. Nature of the carbon chain means in between two carbon atoms that may be a single bond, that may be double bond, that may be triple bond. So that may a single bond means that means it's saturated, or double or triple bond means it is unsaturated. So this gives the primary suffix. If carbon-carbon single bond is present, then a primary suffix is your ANE, and if carbon-carbon double bond is present, it is ENE, and carbon-carbon triple bond is present, then it is YNE. Okay. Now next is secondary suffix. Secondary suffix indicates the functional groups present in the compound. There are several functional groups, that is your alcohol, aldehyde, ketone, acid chloride, cyanide, like this several functional groups are there. So always the functional groups in the compound, they are treated as your secondary suffix. So after the primary suffix, the secondary suffix is used. Okay. Now while adding the secondary suffix to the primary suffix, the terminal E of the primary suffix is dropped if secondary suffix begins with either with a vowel A, E, I, O, U or Y. That means the E of the primary suffix is omitted. It is an omission of E rule, omitted, if the secondary suffix begins with the letter vowels. Okay, we will discuss by taking some examples. We will discuss this point. Similarly, another point is if some numerical prefixes like di, tri, etc. are used before the secondary suffix, the terminal E of the primary suffix is retained. That means if in the secondary suffix the vowels, suppose your functional group alcohol comes 2 times, then you will write the same functional group present 2 times, we will write the prefix di, tri. These are major numerical prefix. So if these are used, then the then the terminal E of the primary suffix is retained. Okay, that will not omitted. Okay. Now next we will discuss some of the rules for doing the iupac nomenclature. What is the first rule? Select the longest continuous chain of carbon atom. It may or may not the straight. That means that chain may be straight chain हो सकता है या ब्रांच चेन हो सकता है. यहाँ पे हमें क्या चूज करना है? We have to choose the longest continuous carbon chain as the parent chain. So if I'll proceed like this 1, 2, 3, 4, 5. No, So total number, maximum number of carbon atoms are present if I'll move from this side 1, 2, 3, 4, 5, 6. Okay, or you can proceed 1, 2, 3, 4, 5. No, or you may proceed 1, 2, 3, 4, 5, 6. Okay. So if I'll proceed from this side 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. But if you proceed from 1, 2, 3, 4, 5, 6, then you have only one substituent. Always treat the select the longest continuous carbon chain by taking maximum number of substituents. So if I proceed from this side 1, 2, 3, 4, 5, 6, then in 2 position one substituent, and in 3 position also another substituent. But okay, so this is the right way to proceed. 1, 2, 3, 4, 5, 6. Okay, the in 2 position there is substituent, in 3 position there is a substituent. So select the longest continuous carbon atom. That may be a straight chain, that may be a branch chain. Okay, now नेक्स्ट पहले हम सब रूल को समझ के जाएंगे, उसके बाद हम एग्जांपल्स लेके सारे क्वेश्चंस को सॉल्व करेंगे. ठीक है. नाउ नेक्स्ट रूल इज the next is, if 2 chains of equal lengths are possible, select the chain with maximum side chains. Okay, that means if there are 2 examples given to you. Okay, these are the 2 chains having equal length. यहाँ पे जो है वो same है. That means if we choose the longest continuous carbon chain, we have to select the chain with maximum number of side chains. Okay, so see here, if I proceed from this side, see here, this is 1, 2, 3, 4, 5, 6, 7. Okay, so if I proceed from this side, then in 3 position there is a substituent, in 4 position there is a substituent, in 5 position there is a substituent, and in 6 position there is a substituent. So total how many substituents are there, or how many side chains are there? 4 side chains. Okay, 4 side chains or 4 substituents are possible. 4 side chains. Okay, is the, if I proceed from this side, see here, if 7 number of carbon atoms, no? If I proceed from, but if I proceed from this side 1, 2, 3, 4, 5, 6, 7. So this is a 7 carbon atom chain. This is also 7 carbon atom. But here you see, in 3 position there is a substituent, in 4 position there is a substituent, and in 5 position there is a substituent. So total how many side chains are possible? 1, 2, 3. That means 3 side chains are possible. Side chains are possible. Okay. So which type you will choose? According to the rule, you have to choose the longest continuous carbon chain with maximum side chains. So maximum side chain is this one, 4 side chains. So this is the correct way to proceed. Similarly, next is in case of saturated hydrocarbons, that means in case of unsaturated hydrocarbons, unsaturated means either presence of multiple bond, double bond and triple bond in the selected chain, then even it violates the longest chain rule, you have to choose, you have to include the multiple bonds in the chain. Suppose here, this is an example. Here in this compound, one double bond is present. If I proceed from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The total 10 carbon atoms. This is the longest continuous chain. But I have to proceed according to the rule. I have to give lowest local to the multiple bond, and by taking the multiple bond, that means there is a double bond or triple bond. In the longest, I have to choose the longest continuous chain by taking the double bond. So here I have to proceed 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9. 5, 6, 7, 8. So this is the longest continuous carbon chain taking multiple bond in the parent chain, and this one is your total substituent. So this is the correct way to proceed. Okay. It may violate the longest chain, it violates the longest chain rule, but we have to include the multiple bond in the parent chain. Now similarly, next here in this compound, how many double bonds are present? 2 double bonds are present. We have to choose the longest continuous carbon chain by taking the 2 double bonds in the parent chain. If I proceed this in this way, suppose 1, 2, 3, 4, 5, 6. This is also longest chain. 4, 5, 6. This is also longest chain. But if I proceed to this side, this one is excluded. But I have to take all the multiple bonds in the parent chain. So 1, 2, 3, 4, 5, 6, and this is your substituent. Okay, so this is the correct way to proceed. Similarly, next, if functional groups are present, then select the parent chain by taking the functional groups, even if it violates the longest chain rule. See here in this compound is a carbon skeleton. Okay, here the functional group is your OH, alcohol functional group. That means always choose the functional group, always give the lowest locant of the functional group. That means the carbon which is linked to the functional group, I have to give lowest locant. Okay, this is carbon number 1. Then I will proceed 1, 2, 3, 4, or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if any functional group is present, then select the parent chain by taking the functional group. Okay, and always give the it may violate your longest chain rule, but you have to take the functional group and always give lowest locant to the functional group. Similarly, see here in this compound, how many functional groups are there? Two alcohol functional groups are there. Okay, now if I will proceed like this, 1, 2, 3, 4. Okay, no, it is not correct because that functional group is not included in the chain. So we have to proceed 1, 2, 3, 4, 5. Okay, this one is your substituent, and there are two functional groups. One is in 1 position, another is in 4th position. Okay. Next, another important point you have to remember that if functional group is a carbon content group, suppose here the functional group is your alcohol, OH functional group. But if the functional group is a carbon content functional group, that may be aldehyde, acid, amide, acid chloride, etc., then select the parent chain by giving the carbon content functional group as number 1. Okay, if any aldehyde, acid functional groups are present, that means the functional group carbon is there, then you have to give lowest locant, that means number 1 to that functional group. Okay, then you have to select the parent chain. Then what is locant? Locant is a number which is used to locate the position of the carbon atoms in the functional group in the selected chain. In a chain, we have to numbering the carbon atoms in the parent chain or in the that means the functional group, etc. Then that number is known as your locant. Okay. Now next rule is, in case of substituents such as alkyl group, halogens, nitro groups, they are treated as your substituents. They are not treated as your functional groups. So if the substituents are present, if they are present same position from opposite ends, then you have to give the lowest number according to in the alphabetical order. Suppose here, if you proceed from this side left to right, 1, 2, 3, 4. So in 2 position chloro, in 3 position bromo. So the substituent position 2 and 3. But if I proceed from right to left, then also the position is 2 and 3. So in which way you have to proceed? According to the alphabetical order, because chloro starts from C, bromo starts from B. So we have to proceed 1, 2, 3, 4. Okay, alphabetical order is the right. Next is, a hyphen is placed. How can you write? While writing the IPS name of a compound, always a hyphen is placed between the name and number. Okay, when I will write 2 methyl, so in between 2 and methyl, one number and name, hyphen is given. In between 2 number, comma is given, or locants. Number means your locant, and comma is present, and in between a name and in between 2 names, no space is used. Okay, that you have to remember. Next point is, if more than 2 substituents are present in a carbon chain, then lowest set of locants is preferred. Suppose here more than 1 substituent, 1, 2, 3, 4 substituents are present. If I will choose the parent chain, then how will you proceed? You have to proceed according to the lowest set of locants. Lowest set of locants means, see here, if I will proceed from this side, this is your 1, 2, 3, 4, 5, 6, 7. Okay. Now see here, in this left to right, what is the set of locants? In 1 position chloro, in 2 position iodo, in 3 position methyl, and in 7 position bromo. Okay, this is the set of locants from left to right. But when you proceed from right to left, what is the position? 1, 2, 3, 4, 5, 6, 7. So here, see here, what is the position? The position is in 1 position and another is 5, 6, 7. Okay, so see here. How can you compare the set of locants? First of all, this is 1, 1, same. Next is, this one is 2 position, this one is 5 position. Always compare term by term. In the set of locants, you have to compare term by term. So in the first term, both are same, but in the second term, it is 2, it is 5. So you have to proceed from left to right, because the set of locants lowest number is from left to right. Okay, so this is the correct way to proceed. This is the correct way to proceed. Now if lowest set of locants is on the both sides are same, this इस साइड में जो भी सेट ऑफ लोकेंट्स आएगा उस साइड में भी सेम सेट ऑफ लोकेंट्स आएगा, देन आप क्या करोगे, देन प्रेफरेंस इज गिवन टू द साइड अल्फाबेटिकली, देन वी हैव टू गिव प्रेफरेंस टू द अल्फाबेटिकल ऑर्डर. Now see here one example is there. See here one example is there. If I number from left to right, if I proceed from left to right, suppose see this is your 1 2 3 if I proceed from this side 1 2 3 4 5 6 7 8 9, so all total 9 carbon atoms are there, in which your 1 2 3 4 in this is the 4 position there is methyl, in 5 there is a chloro, 6 chloro, 7 chloro, 9 chloro. So from left to right, what is the set of locants? The set of locants is in 4 position, then 5 4 5 6 7 9, okay, 4 5 6 7 9. Now in this side, if you proceed from right to left, the set of locants is, this is your 1 in 1 position, then 2 3 position, 4 4 5 5 6 6, okay. So you compare here 4 1, in the lowest locant is this side, so you have to proceed to this side, right? This one is the correct way to proceed, okay. Now listen, to explain this example we have to take that means to explain this rule we have to take one example. See here, in this compound, first of all, if we start from left to right, this is 1 2 3 4 5 6 7 8 9 carbon atoms, okay. Now what is the set of locants here? 1 2 3 1 2 3 7 8 9 7 8 9, okay. Now if we move from right to left, then what is the set of locants here? See here, 1 2 3 4 5 6 7 8 9, okay. Now here set of locants is 1 2 3 1 2 3, then 7 8 9 7 8 9. So when from both these sides the set of locants is same, then you have to give preference to the alphabetical order. Now see here, if you move from left to right, in one position there is bromo, in right to left also one position bromo, but when you will see the second one here, the second position there is a iodo which starts from I, and in right to left in second position there is a chloro which starts from C, chloro C. So C comes first, then I, इसीलिए आपको राइट टू लेफ्ट प्रोसीड करना चाहिए, एंड दिस वन इज द करेक्ट वे टू प्रोसीड, ओके. Now next rule. Next is, if carbon-carbon double bond and carbon-carbon triple bonds are present in some compounds, its same locant, carbon-carbon double bond is preferred because E of the suffix ene is alphabetically preferential and compound named accordingly. Okay. So suppose this is the example where in this compound both double and triple bonds are present. Okay, then if which in this case, if you move from left to right, in one position there is a double triple bond, when you move from right to left, in one position there is a double bond, okay, then which way you have to proceed? Now according to the rule, if both are present in the same locant position, position number 1, then preference is given to double bond because ene is comes first, then yne. So in which way we have to proceed? 1 2 3 4 5 6. So this is the correct way to proceed, okay. Similarly, if more than one double and triple bonds are present in the compound, then the prefix diene or di-yne. If more two double bonds are present, then we can write di, and the prefix is ene. If two or more triple bonds are present, two triple bond is present, then for triple bond yne, and before the suffix we have to write di-yne, diene. इसी तरह अगर 3 है तो ट्राई, 4 है तो टेट्रा, एक्सेट्रा is used. Okay, so see here, in which way we will proceed, because this is the lowest locant, 1 2 3 4. Okay, so this is the right way to proceed. Two double bonds are present, we have to write di-ene. Okay, next is, if side chain is branched, then what is the rule? See here, if side chain is branched, then carbon atom of the branch that attached to the main chain is numbered as 1 and is generally written in brackets. So in this way, in this compound, suppose here this is not a methyl group, this is a group, or this is a group which is already again branched. So in this total organic compound there is a branch chain is present. Okay, for that group if there is some name you can write the name also, or again you have to do the naming by giving number 1 to the carbon atom which is directly attached to the main chain. So see here in which way we have to proceed. Okay, see here, if I go from this side 1 2 3 4 5 6 7 8. Okay, if I proceed 1 2 3 4 5 6 7. Okay, if I proceed 1 2 3 4 5 6 7. So in which way we will proceed? Maximum number of see here, if I proceed, maximum number of carbon atoms are present in this straight chain. Okay, but we have to move from this side 1 2 3 4 5 6 7 8. Okay, so in fourth position there is a substituent and maximum number of carbon atoms are present in the straight chain from right to left. Okay, so this is one substituent, this is known as isopropyl group present in this in the fourth position. Similarly, see here, there are another group, this is already branched group. Okay, this is substituted substituent which is present directly attached to the parent chain. So in which way you have to proceed? Either from left to right or right to left. See here, so in this compound we have to proceed from right to left. Like see here 1 2 3 4 5 6 7 8 9 10. Okay, so how many side chains are possible? See here, in 6th position there is a side chain 1. In 8th position there are 2 side chains. Okay, so if you go like this, the maximum number of carbon atom is 10 and the substituents are total maximum number of substituents are 3. Okay, but another one point that you have to observe, see here, if you will proceed from right to down, then in the first locant or first substituent comes at 6th position. Okay, but we have to give lowest locant to the substituent while choosing the longest continuous chain or parent chain. So see here, instead of this, if I choose the chain, parent chain from this side 1 2 3 4 5 6 7 8 9 10, then what are the set of locants? 1 2 3, that means in 3 position there are 2 side chains, 2 substituents, and next is in 4 5, in 5 position there is a substituents. Okay, so total set of lowest set of locants 3 3 5, but if we move from this side to down, then start is 6. So we have to choose the lowest set of locants. Okay, so this is the correct way to proceed, right? Now next we'll do the answers or namings. Now what is the important note? While writing the substituents in alphabetical order, the prefixes iso, neo are considered to be the part of the name of alkyl group. Okay, but the prefixes secondary, tertiary are not considered to be the part of the name. That you have to remember. Okay, in this case I can write isopropyl. Okay, but iso, neo, this one can be considered in the IUPAC nomenclature, but secondary, tertiary, these terms are not considered.